So what's new in number from last year to now? First thing, we now support Python 3.7. That's great. And we also have a deprecation plan for Python 2. That's even better. Yes. A lot of the NumPy functions now are, quote, working with a caveat that every time there are optional arguments and the return type changes because of the optional arguments, we usually don't support that. But you can check out detailed changelog to find all documentation to find the API that you want. There are now list comprehensions, closures, and array comprehension supports. So you can have lists below in one line and then counting out the list, or you can put it in like the numpy.array with the list comprehension that actually gets optimized. You don't actually create a list. Then there are also name tuples, nested lists. So there are more Python semantic that we support. We are always trying to make the error messages less cryptic, and comes to our sprint, and we can talk more about that. And there will be a slide about better error messages too. And we are trying to promote this concept called CUDA array interface. If you are familiar with the NumPy one, just the Dunder array interface, this is essentially the same thing for GPU data. And we are working with CuPy we're trying to integrate that into CuPy so that you can not just use our array, GPU array, but use other people's GPU array. And eventually we probably get to PyTorch and all TensorFlow and all that. We now publish binary builds, many Linux, Windows, Mac, along with our kernel packages. Then you don't need LLVM installed or compiled on your own. Performance improvements. There are now better automatic SIM devectorization that has been there, but now it's just better with LLVM 6. So you can get, if you have AVX 512 in your Skylake Xeon that would work. It works even better with SVML. In order to enable that, you need that fast math equals true. Parallel accelerator. This is contributed by Intel. I believe last year they already have talked about this. But if you set parallel equals true, it's kind of like OpenMP for Python. So if you swap your for I in range, you swap that with for I in number.p range, it turns your loop body into a parallel execution on multiple threads. It's all automatic. And there are more like loop fusion and array optimization stuff that kicks in. So it's really fun. There's also a stencil API if you write a lot of windowed functions. More about the SVML support. It's short vector math library from Intel, and whenever you have transcendental functions like sine, cosine, it helps and turns that into more detail later, but it can make your code 10x faster, and this is an example HTML annotation working, so you can, inside IPython notebook, so you can actually inspect your code. Okay, and so also a lot of new hardware coming, ARM v7, ARM v8, Power 8 and 9, AMD GPU, I'm going to skip all that, number of features. Others, like we're trying to make enable that you can call Python, this object code within a NoPython block. Also more diagnostic. And comes to our sprint, and I will tell you more. Okay, thank you.
All right, next up is Sylvan, and on deck is Aaron with SymPy.
So about 3 minutes. So what is Xtensor? Xtensor is a modern C++ template library for fast n-dimensional array tensor algebra. So too long didn't read, NumPy for C++. We've got language bindings for R, Python, Julia, and it's built upon solid foundations meant for speed and ease of use, so XMD and XTL. We also have bindings for libraries such as BLAS and FFTW, and utilities to read various file formats from Xtensor. So from NumPy to Xtensor, we have a cheat sheet available on the website, and longer examples translated from NumPy to Xtensor in our benchmarks. So quick walkthrough, we have very similar containers, initializers like linspace, logspace, once, mesh grid. We support broadcasting and views and new access, so an API that is really, really close to that of NumPy, but in C++. So iteration, concatenation, split, etc. So this example here is an example of a NumPy code and the corresponding C++ code that does the same thing using extensor. And we don't have the slice API in C++, the slice syntax, but you can recognize that it's almost the same thing. So extensor is fast, so it's continuously benchmarked for basic operations and a collection of real-life examples taken from the Python benchmarks. So we also make explicit use of SIMD instructions for the target platform, including AVX512 and Neon, and etc. We also make use of template expressions to implement lazy evaluation, unrolling most of the loops, and preventing allocations of temporary variables. So here's a quick example of extensor on compared to other frameworks on a number of real-life examples, like a few dozen lines of Python. So we compare with Numba and Python and SciPy with all optimizations enabled. And we're doing pretty good. Just to keep us honest here, there was a performance bug on the reverse CumSum that was not going really fast. And that's because we were, it was fallbacking on a version that was not making use of all the optimizations, not really detecting that things were contiguous in memory. You can try extensor online with a new C++ kernel in a Jupyter notebook. So there is a binder for extensor, so check it out. It really provides an API and an experience that's similar to that of NumPy in a Python notebook. So what's coming? Ongoing performance improvements, so solve the performance bugs, SIMD acceleration for complex numbers and character operations, and a data frame for C++ called xFrame with an API and a data model very, very similar to that of PyData Xarray. So some credits. It's not a one-man show. The three main developers are, beyond myself, Wolf Volprecht, who's been working a lot on optimization of performances lately, and Johan Mabil.
Hello, this is Aaron from SymPy, and next on deck is Steven from Scikit-Image.
Hi, I'm Aaron Muir. I'm lead SymPy developer. For those of you who don't know, SymPy is a symbolic mathematics library. So here's some examples of some things you can do in SymPy, like take symbolic determinants, solve equations symbolically, do symbolic integration. It's a fully featured computer algebra system. And so this year we have 7 Google Summer of Code students working on improving our SymPy stats module. We have a student who's making more progress in the Ruby integrator, which is a pattern matching integrator from Mathematica. There's a student working on rich beam solving systems. There's a student working on AutoLev parser. If anybody here knows what that is, it's a mechanics thing. There's a student improving the group theory module. We have a student working on all kinds of transforms and convolution, linear recurrence evaluations. And we have a student working on our solvers module. So these should be coming down the pipeline after this summer. Just this past Monday, we did our 1.2 release. So the release notes are here. There's actually a lot of changes, like over 700 pull requests. So check it out. But the major ones, we no longer support Python 3.3, and we're going to drop Python 2 in, next year. We have experimental LaTeX parsing. So if you have a string that's a LaTeX expression, you can parse that into a SymPy expression now. And that requires installing the Antler Python runtime. We have some experimental support for derivatives of matrix expressions with respect to matrices. This is a very commonly requested feature, and we're now starting to support it. Most of our Google Summer of Code projects from last year are now included in this release. So we have lots of improvements to the vector module, this new int poly submodule for integrating polynomials over polytopes. A ton of improvements to code generation. This was the project that I mentored. So if you use SymPy to do code generation, check out the new CodeGen submodule in SymPy. There's a lot of good stuff there now. And improvements to the group theory module. And like I said, there's just tons and tons of changes. I'm actually still compiling these release notes, but go check them out if you use SymPy, and please update. That's it, yeah.
So this is Stefan van der Walt with Scikit-Image, and on deck is Nathan for YT.
Thank you. Good afternoon, everyone. Thank you for this opportunity to update you on Scikit-Image progress. So Scikit-Image is an image processing library for Python. This is just sort of a snapshot of random images from the gallery. If you really want to see what Scikit-Image is all about, scikit-image.org and click on the gallery where we have many more examples. Notable developments, we just released 0.14 in May, 180 PRs plus, 67 committers with 23 reviewers engaging. But I don't want you to get the wrong impression. The core team is just about 4 or 5 active contributors. And this is a long-term supported release. Just a few snapshots of new features included. You'll see the Chan-Vese segmentation here, morphological snakes, HAR-like features like salient feature detection, and hysteresis threshold detection. And again, more at our gallery. Very notably, though, is that we also stepped away from Python 2.7. So this happened in PR 3000. Yeah, the timing of that, like we had numerous discussions on the list every time it didn't happen, and then finally the timing was exactly right, PR 3000. While we don't support Python 3 any longer in the development version, our long-term release will support Python 2, sorry, we'll support that for another 2 years. So technical roadmap, we're continuing our improvement of n-dimensional support, so no longer just flat images, but also volumes, etc. We're standardizing indexing conventions throughout the library. We're working hard on handling metadata better, improving the scaling and speed. And we're also working on setting up a roadmap with priorities so that we can better engage with the community on how we need to move forward. But most of our priorities are currently figuring out a lot of meta issues like governance, how to grow our community, how to make our website more people-centric, how to figure out our vision, mission, that sort of thing. Yeah, we'll be here on Saturday. If you want to engage in the sprints, we'd love to have you there. Thank you.
Next is Nathaniel from YT, and on deck is Prabhu from MayaV.
So good afternoon, everybody. So my name is Nathan Goldbaum, and I'm going to present about YT. So YT isn't as familiar with some of these projects, so I wanted to quickly go over what YT is. So on the left here are the logos of some major astrophysical simulation codes that all have unique, bespoke output formats that are relatively complex. It would take a lot of time to parse and figure out how to load them and deal with them. So what YT does is it has the ability to ingest data from all of these different complex research data formats for volumetric data, integrate with the rest of the SciPy ecosystem to produce beautiful analysis and visualizations like on the right. So YT is a NUM-focused sponsored project, and our code is hosted on GitHub. YT is a community of practice. All of these people have contributed to YT over the years. There's also a link to an archive link on the bottom where Matt Turk, the founder of the YT project, explained how he built this community from nothing, basically. And I also want to especially emphasize these people I've highlighted. They're all YT project members who have contributed substantially. Especially 2 of them Abhishek Singh and Ashley Kelly are Google Summer of Code students this summer who are working on adding new, Abhishek is working on improving the test suite, Ashley is working on improving support for smooth particle hydrodynamics data. New in YT 3.5, which is due out soon, there's a whole bunch of minor improvements and bug fixes, greater than 200 merge pull requests. The big new feature, I think, is substantial improvements to the Ramses front end. Ramses is a code that's very popular in Europe and that has lots of users there. These are all of these people that I've listed here, I've never met, and they just found YT, found it was useful, and then improved it for their own needs, and now everybody gets these improvements. And also, YT 3.5 will be the last version to support Python 2.7. And over here on the right, this is like my favorite YT tweet all year. John Wise is a professor at Georgia Tech. His first year grad student was able to take one of his simulations and 3D print it without knowing a whole lot about YT or Python. The formatting got messed up a bit. So YT 4.0 is YT beyond astrophysics. So we have a grant that's publicly available on Figshare. We're hoping to have the first release for YT 4.0 in 2019. And this will be having explicit support for data from oceanography, plasma physics, seismology simulations, geophysics, and meteorology. We have an open postdoc at the National Center for Supercomputing Applications at the University of Illinois. If you'd be interested in working on YT and you are in the job market right now, please give our job ad a look. If you have questions about that, please contact me. And also I want to highlight the YT extension ecosystem, which has sort of developed in the past year or so. So people have created their own YT packages that depend on YT, and we're sort of have an official mechanism for registering them and associating them with the rest of the YT project. So I just want to highlight all the cool things that are happening there. That's it.
Next we have Prabhu about MyVI, and on deck is SymPy.
Hi everyone. Try and keep this short. So what is MyVI? So MyVI is a package that lets you do 3D visualization. It works on an interpreter, as you can see here. So with one line of code, you can take NumPy arrays and directly visualize them as in 3D and interact with them. It's also an application, so you can actually treat it as an application to load up visualization files that you've saved, and then perform the same exact visualizations that you've done before. With pure Python, you can just do them with the UI as well. So it's also completely UI driven, which means you can either script it or you can use the UI. Above that, you can also make dialogues, rich dialogues. So this particular dialogue probably has about 100 lines of code to make it up, and you can explore the Lorentz system if you want, or you can even change the equations live, and it'll update live, and you can interact with it and explore the vector field. So it's a very general purpose visualization system that you can use. And recently we also added Jupyter support, so you can embed a subset of the kind of things that you can do with MyRV, but you can at least do some of them on a Jupyter notebook and embed them as X3D visualizations that you can load up in a browser and interact to a reasonable extent. So it's an old package. It's been around for more than 15 years. It's very scriptable, seamless NumPy integration, powerful command line options, and it also has this cool feature where you can turn on automatic script recording, which means you turn a button, and then you start doing UI interactions, and it'll automatically record scripting actions that you can, so you can automate your visualization by just running the script instead of clicking the buttons. So it does all of that for you. So it used to be the hardest to install package on the planet, and I think I'll take anybody up on that. I don't think I'll have any contenders on that. But it is now pip installable, and that's a pretty big. So this is because of some collaborative initiative between the Kitway guys from last SciPy, where they managed to get the VTK system building well enough that we can make wheels. So VTK 8.1.0 and 8.1.1, which are the latest stable releases, are actually available as wheels on PyPy on all the major platforms. So this makes it easier to install with pip. It has Python 3 support. It's been there for a while, but it's very stable now. We have PyQt support. We also have PySide 2 support. There's also some useful learning material that I've been putting together that's useful for either a 2-day workshop or like a 4-hour workshop that you can check out. So the plans going forward is to make installation a bit easier. This is, I said done when I created these slides, but then I realized there's a bug that I have to fix, which I will fix during the sprints. Basically, it makes optional an extension module that used to be there. So even if you're installing it without a compiler, it should be pip installable. And I think I've messed up something there, but I think I'll fix it over the sprints. PySide support was supposed to be done, but it was already done. It's supported in 4.6.1, so PySide 2 is available. Various issues need to be fixed, support more data formats, and interop better with a bunch of new tools that are available now. Thank you.
All right, so next we have David with SymPy, and on deck is James Bendar with PyViz.
Yeah. I also made the brave decision to have a presentation about an OpenGL library and not have any visualizations, so stick with me. So if you haven't heard about SymPy, SymPy is a high-level OpenGL wrapper. It has plenty of backends for all the different GUI frameworks. It also has a backend for Jupyter Notebook, which supports just about everything except for volume rendering completely, but at this point use IPyVolume. It uses an intermediate representation of the GL calls that it's doing. So theoretically, you can send your OpenGL operations to a remote rendering program. It has a low-level glue API, so you can, it's basically an object-oriented wrapper around the GL calls, so you create a texture object, and all of the setting of the data and deletion of the texture object in the GL side of things is all handled on the Python class side. It also has a higher-level scene and visual API, where you can create these higher-level Python classes that have shaders associated with them, and all of the communication with the OpenGL layer is all handled with the glue layer underneath that. We also have a high-level plotting API. It's not as full-featured as the things that have been around forever, like Matplotlib, but you can do some basic plots and get some really nice performance with updating the data in real time. So what's new with SymPy? It's alive. Last time people heard of it was probably 2015. I needed it, a couple other people needed it, and so we asked the previous maintainers, can we have it back? And they said, okay, sure. October 2017, we came out with a new release. I hope to have the next release, 0.6, out in the next week or so, but I've been saying that for the last 2 weeks, so we'll see how that goes. The new release will have texture-based color maps, so we can support a wider variety of color maps, where before we were implementing these color maps as if-else blocks in the GPU shader language, and now they're actually just textures, and so you get nice interpolation with that. PyQt5 compatibility is the current thing that's holding me up because Travis doesn't want to play nicely. If there are any experts on PyQt5 OpenGL stuff, please come talk to me. There are plenty of small performance improvements across different areas in SymPy. We have other various bug fixes, and we're trying to catch up with all of the backlog from the lull in development. Future features, we're hoping to start supporting newer OpenGL features like geometry shaders, hopefully tessellation shaders after that. My personal projects deal a lot with satellite imagery data, so there's geographic projections associated with that. I hope to add transforms for that, so you can show a map and have and have lines show up. And if anybody can help me maintain it and help join us, especially if you're good with OpenGL, come talk to me. Thanks.
Our final speaker is James, talking about PyViz.
Hello, thank you. PyViz is a project that didn't exist a year ago, but as you'll see, it's come out of other projects that do, and so it's new for this SciPy. You'll probably see it at various points. You might have seen it already. But what it is a little hard to explain. It's a coordination project. So all of the projects on the right here already existed. And what's new is that we're recognizing that we need a name where we can share a website and we can show our tutorials that show how everything works together. So the people involved in these libraries, or at least us using some of the libraries, all working together to get things to play nicely together and not overlap in features and solve problems. And you'll see what that means here in a second. If you look at what those projects have done over the past year, each of these bullet points, on the right of it, I list the projects that are involved in those bullet points. So we added graph and network plots, but we added them to bokeh, HoloViews, GeoViews, and Data Shader at the same time. So that allows you to easily switch between geographic and non-geographic contexts, small data and big data, low-level implementations, higher-level data science implementation. And so we basically added graphing and plotting of networks to this entire ecosystem at the same time in ways that work well together. And we did the same thing with other things in this list. We took some inspiration from Seaborn, but we implemented it as a fully interactive JavaScript-based plot. So if you have a distribution plot, you can, like the ones in the upper corner here, you can select and zoom in, and everything is linked nicely. And so you can play around with it in a way that you couldn't with the original Seaborn. We added various plots. Any plotting library you ask for their new updates, there's always going to be new plotting types. So we didn't previously have Sankey plots or hex tiles. Radial heat maps. If you were in the geo track, you'll have seen examples for tri-mesh plotting of very large irregular grids, and also, but we're not mentioned there, but we also have very fast plotting of regular grids where it's dynamically resampled as you're zooming into it. That's added to HoloViews, GeoViews, and for large data implemented with Data Shader. And previously, things like Cartopy would work well in Matplotlib and give you arbitrary geographic projections, but you couldn't make them interactive in bokeh. Now you can. So you can have this plot here will be arbitrarily, these two would be arbitrarily interactive, zoom in, pan, and so on in bokeh. And added streaming support for streaming data sources automatically updated. Also created a new project called hvplot that is a replacement for pandas.plot. You can now do import hvplot.pandas and then do pandas.hvplot, and you get a fully interactive bokeh-based plot for the replacement for the previous static matplotlib one. And that works for pandas, for Xarray, and several different other data libraries. Maybe that's in here. We also added drawing and editing tools for bokeh and HoloViews. So if you have a plot, you can annotate it, and you can persist the annotation, you can pull it out into Python, work with it, save it, and come back to it. So you can use it as more of a GUI toolkit. And various other features like Jupyter Lab support. Oh, there's hvplot. So just all of this is findable from pybiz.org. And if you have these slides, you can click on them. Where are we headed? As we mentioned in the BOF today, we're working a lot on making dashboards work well. We're working a lot to make it easier to link widgets, plots, and plots between each other, particularly in the static case where it's all HTML and JavaScript and no Python involved in the deployment. So we're trying to encapsulate common patterns of working and make it so you no longer need Python when you deploy and deliver it. And we're particularly working in the context of geospatial applications and machine learning with and without geospatial applications. And we're also working to embed Data Shader throughout our pipelines so that anything where you have very large data, you can switch to that whenever you feel like. So, thank you.